Welcome, my dear students, to the new topic, that is interrupt. As in the last video, we discussed the accessing of the IO devices topic. In the accessing of IO devices topic, as we already discussed that for to accessing the different IO devices and for to communicate between the memory and processor or the processor and IO devices, we have to require the two different way. There are two different way to communicate with that one. That first is the interrupt method and another is the direct memory access method. So now here in this video, we try to discuss the interrupt, all the details part related with the interrupt. Now exactly the interrupt means what? An program controller IO, when the processor is continuously monitor the status of the device, it does not perform any useful task. An alternate approach would be for the IO devices to alert the processor when it become ready. So there are two different ways that do so by sending a hardware signal to which is called as the interrupt to the processor, or at least one of the bus control lines which is called as the interrupt request line is dedicated for the purpose. Now actually in the certain in many situations the task can be performed by the processor and it wait for an I devices to become ready. To this to do this we can arrange the IA device which alert the processor when it is ready. It does so by sending a hardware signal which is called as the interrupt to the processor, and that particular signal we call it the interrupt. Whether it is to be sure is you are ready or not on the whether to be a we have to perform certain another task or so at least one of the bus control lines which is called as the interrupt request lines, which is usually dedicated for this purpose, and the processor can instruct the IO devices to interface to activate the lines as soon as it is ready for the data transfer. And since the processor is no longer required to continuously check and to continuously check and check the status of the external devices, it can perform other useful function also while waiting ended up by the interrupt such as waiting period can ideally be to be eliminated. For that purpose, for example purpose, we will consider a task that required some computations to be performed and the result to be printed on the line printer. This is followed by the more computations and the outputs and so on. Let us program the consist of the two routines, two subroutines, that is compute and print. For that purpose, we will take a two compute and print. These are the two different terms. For assume that the compute produces the n lines of the output to be printed by the print routine, which required the task can be performed by repeatedly executing the first compute routine and then print route. The printer accepts only one line of the text at a time, and hence the print routine must send one line of the text, wait for the printed, and then send the next line and so on until all the result can be printed. There is a disadvantages of this approach is that the processor spend the considerable amount of a time waiting for the printer to be away to be ready, and if it is possible to overlap the printing and the computation, that is to execute the compute routine while printing is in a progress, which is a faster overall speed of execution. So this will be done. Here the some related that interrupts terms are to be work. Here the processor is executing the instruction which is located at address I. Here the certain we have there is a graphical representation. It shows that there is a certain program, and in that particular program there are n number of instructions, and between that instruction there are certain interrupts are to be used, and as that interrupt are to be comes, interrupt service routines will also there, so that routine which executed the response of to an interrupt request which is called as the interrupt service routine. Okay, so when the interrupts occur, control must be transferred to the interrupt service routine, and but before transferring the control, the current contents of the program counter must be saved in a certain location. That is, program counter must be saved that particular address. So this will be enable the return from interrupt instruction to be resume executed I plus 1. The return address or the content of the PC, that is the content of the program counter, are usually stored in the processor stack also. Whenever the printer comes ready, it alerts the processor by sending an interrupt request signal in the response to the processor interrupt execution to be compute routine and transfer control to the print routine. The print routine sends the second line to the printer and again execute it. It is just like that, the compute and print. Like, we can consider it as a program 1 as a compute section, and this program 2 interface with the print routine. So now the print routine sends the second line to the printer and it again is again suspended. Then the interrupt compute routine resume the execution at a point of an interruption. This process continues until n line have been printed. The print routine is restarted whenever the next set of the n line is available for printing. And if the compute takes longer to generate n lines, then the time required to be print them. The processor will performing useful computation all the times. The routine executed in response to interrupt request, which is called as the interrupt service routine. And this is the print routine in that our examples. The interrupt reassembles the subroutine call. Assume that an interrupt request arrives during the execution of the instruction, which is shows in the graphic representation. But here we will take the simply programs and the interrupt service subroutines. The processor first complete execution of the instructions I, then it load the program counter with the certain address of the first instruction of the interrupt service subroutine for the time being. And let us assume that this address is hardwired in the process. After executing the interrupt service subroutine, the processor has to be returned the instruction, and that instruction will be in terms of the I plus 1. Therefore, and when the interrupt occurs, the current contents of the program counter which points the particular instruction, that is I plus 1, which must be put in the temporary storage. The return from the particular interrupt instruction at the end of the interrupt service subroutine, which reload the program counter from the temporary storage location, which causing that execution to be resumed at an instruction of I plus 1. In a mini processor, the return address is to be saved in the form of the processor stack. Alternately, it can be saved in a special location which is called as a such as a register, which is provided by certain purpose. As a part of the handling interrupt, the processor must inform the device that its request has been recognized so that it can be removed and interrupt request signals and special control signals on the bus, which is called as the interrupt acknowledge signal, which is used in some interrupt scheme also. Here, the treatment of the interrupt service routine is to be very similar to that of that subroutine. However, there are the significant different. There are certain different between subroutine and interrupt service routine. A subroutine performs tasks that is required by calling program. Interrupt service routines may not have anything in the common with the program interrupt. Interrupt service routines and a program that is interrupt maybe belong to the different users. As a result, before branching to the interrupt service routine, not only the program counter but also the other information such as condition code flag or the processor request register are used to be both by both the interrupt program and interrupt service routine must be stored, and this will be enable the interrupt program to resume execution upon a return from the interrupt service routines. Saving and restoring of the information can be done automatically by the processor or explicitly by the instruction computer. There is a common alternative is to be have the transfer of the data between processor and IO devices interface to accomplish the same purpose. The execution of the instruction in the interrupt service routine that access the status or the data register in the device interface implies that the device its interrupt request has been recognized. An important difference between the interrupt service routines and subroutine is that the subroutine performs the function which is required by the program from which is called, and whereas the interrupt service routines may have the nothing to common with the program which is being executed at that time and interrupt request is to be received. In fact, the two programs often belong to the different users, and hence, before starting execution of the interrupt service routine, the any information that may be altered during execution of the program routine must be saved. This information must be restored before execution of the interrupt program is resumed. In this way, the original program can be continuous execution without being affected in any way by the interruption. Expect for a time delay. The information that must be saved and restored typically includes the conditional code flags and content of the register which is used by both interrupt program and interrupt subroutine. So this is all about the interrupts will becomes in that will be we will discuss the interrupt part is, and then also next video we will again try to discuss the interrupt part in more details. Keep watching that video. Thank you.